Hi students, it's Mrs. Young again. I am going to go over the 1.2.3 worksheet with you. The idea is that you have attempted this work on your own and you are using the video as a quick check. And if you have any questions that did not get clarified in the video, please make sure to email your teacher and ask. This lesson will be used as a foundation for what you do in class the next time we see you. So on the warm-up, we're going to review some stuff from Algebra 1 that will help you through the rest of the problems. We need to know how to graph a line. So if we remember, the coefficient of x, or the number in front of x, is your slope, m, and I think your 8th grade teacher said m is how you move. It is rise over run. And then the b value is the number that does not have the x with it. It is a constant, and that is where you begin. So on the equation provided in number 1, we are going to begin at a y-intercept of 4, and we are going to move down 3 and to the right 1 to generate our next point. We always want to move down and to the right, I should say, and the negative tells us that we're moving down. Then we have to write the equation in number 2 of the line graphed below. So what I did is I identified 2 points that are lattice points, which means it hits those little corners of your grid and you can easily read them. And I drew in a slope triangle. So it goes over 2 and up 1. Our rise is the numerator and our run is the denominator. So our slope is 1 over 2. We begin at our y-intercept of 1, so our b value is 1. This equation will then be y equals 1/2 x plus 1. On 1-68, you were supposed to just make some observations here. So hopefully you came up with each triangle is equidistant from the line of reflection and its image is directly across from the line of reflection. It's not tilted up, it's not tilted down. And a lot of students kind of connect that you're moving in a manner that is perpendicular to the line of reflection. And you might have noticed that in class earlier in the week or last week. All right, so 169 is really where we do some exploring. So I went ahead and plotted the line in part A. And it said that we're going to use tracing paper to translate our graph up. So when I use tracing paper, I'm going to make sure that I get the origin on there because that's going to kind of be an anchor for me and help me see how far I'm moving everything. I'm going to trace my line and get those points on there that I used, my y-intercept, and then the next point that I created with my slope. And I'm also going to put my slope triangle on my line because I'm going to want those numbers as I do this problem. So part A says we are going to translate up 5 units. Okay, well, let's see. So I'm going to be up there if I go up 5. And it wants to know what is the relationship between the 2 lines and how do their slopes compare. So you can see that those 2 lines are parallel and that slope triangle did not change. It is still a rise of 3 up and a run of 5. So the slopes are actually equal. Now use tracing paper to rotate 90 degrees clockwise about 0, 0. All right, this is where the origin comes in handy. So we're gonna pin down the origin and we're gonna rotate clockwise. So in the direction that the clock moves, I almost went the wrong way, 90 degrees. So I'm gonna watch that plus sign to know when I've gone 90 degrees. So there we go. Describe the relationship between the line and its image. So hopefully you can see that these create a right angle and these lines are actually perpendicular. And then it says, look at the slope of the original line and the rotated line and make any observations that you can. Well, we're using the same slope triangle. It's just been turned so that the rise we had before is now the run and the run is now the rise. One line is going up and one line is going down. So our new slope is going to be down 5 and over 3. So new slope is down 5 and to the right 3. So what can we conclude from that? Well, part A told us that the slopes of parallel lines are equal And the slopes of perpendicular lines, well, let's look at this. It was 3/5. Now it's -5/3. So you will see people call this either negative reciprocals or opposite reciprocals. And either one is okay in my book. Okay, so negative reciprocals or opposite reciprocals in this box is super important, and we will be using that when we see you next time in class. All right, now it's just gonna have you go through some other examples on 1-70 and kind of confirm those observations that we just made. So A says use tracing paper to rotate each line with its slope triangle, either counterclockwise or clockwise, 90 degrees, and find all of your new slopes. So I'm gonna trace my origin to kind of keep me anchored, and then I'm gonna trace my lines and their slope triangles. Now, a big complaint students have is I can't really see those grid lines. Well, do the best you can, and since you're tracing your line anyway, if it was a little off, at least your new one's the same amount off as your original, so it really won't make a big deal in your observations. And that is also why I am drawing in these slope triangles. Okay, so we are gonna rotate 90 degrees, and it does not matter which way, so I'm just gonna go that way. And I'm gonna get that plus sign lined up, and then I'm gonna write down my new slopes. So this guy is going down. It's going down 3 and to the right 1, so I'm gonna write down a -3/1. This one is also going down. Remember that you read a graph like you read a book. So that is going to be -1/1. This one is going up. It's going up 5 and to the right 3. How does the slope of each rotated line compare to the slope of the original line? So in other words, are we still seeing this opposite reciprocals pattern? So kind of, this one's not the most obvious to look at. I mean, ones aren't super special. So I'm gonna focus in on these. So did we flip numerator and denominator? Did we find the reciprocal? Yes, we did. Are they opposite signs? Yes. So over here, did we flip numerator and denominator and find the reciprocal? Yes. Do we have opposite signs, one positive, one negative? Yes. So we are still seeing opposite or negative reciprocals. And again, you can call it either one, opposite. Making sure I'm spelling that right. Okay, so opposite reciprocals or negative reciprocals. Use the patterns from your work you have done to describe the general relationship of the slopes of perpendicular lines. We have done that already, so we are going to put it in your terms, flip the fraction and change the sign. So I had a student last year call this perpenflipular. And we had a sign about it in class, and I thought that was a really handy way to remember that we are gonna flip our fraction and flip our sign. All right, I know there's some examples on the back that we will want to do in some more detail. All right, so this one is just going over more generally the pattern that we're seeing where we flip our rise and run and we change the sign. Part B is pretty interesting. What happens if your slope is 0? So a slope of 0 means a rise of 0 and a run of some number. So if we do this rotation and we flip our rise and run and flip our sign, our numerator would be the negative of whatever that number is, and it would still be 0, but now the 0 is on the bottom. And here's the issue. We cannot divide by 0. So that is going to be an undefined slope, which means it is a vertical line. A slope of 0 is a horizontal line. All right, 172. A lot of students actually make these observations on the problem on the front that had a similar diagram here. So when you go ahead and connect these, you should notice that your lines are parallel and they all have a slope of -1/2. And because they have the same slope, they are in fact parallel. In geometry, we abbreviate parallel with this symbol here. And then it wants you to look at the relationship between the segments here and this line. So hopefully what you're gonna notice is that this portion is congruent to that portion. So from P to the line of reflection and from P prime to the line of reflection, it is the same distance. And this little marking means congruent or equal. Okay, now these guys are congruent to each other, but a different length from up here. So we're gonna use 2 marks. And then down here, these are congruent to each other, but different from both of those. So we can use 3 marks to indicate that they are congruent. They are the same distance from that line of reflection. Part C, use slope to confirm that the line of reflection is perpendicular to the line segments connecting each original point and its image. So we found up here that these have a slope of -1/2. And if you find the slope of this line, it is 2. So these slopes are, in fact, negative reciprocals or opposite reciprocals, proving that our lines are perpendicular. All right, this slide is pretty important and is what we are going to work on the next time we see you in class. We're going to do some extra practice with this and make sure everybody has a grasp on it. So we're going to practice writing equations of lines. There's several different ways that you can do this. I know Mrs. Pierce focused a lot on point slope form, which is handy and pretty easy to use. This one says write the equation of the line parallel passing through this point. So I'm going to go ahead and do point slope form because I know many students are familiar with that from Algebra 1. The key is that the parallel line will actually have the same slope as the given line, which is -4. So I know that that's going to be my slope, and then I know these guys here. Okay, so point slope forms means we're going to do y minus the y value, and then equals your slope, which is -4. And then we're going to do x minus the x value. And honestly, on your AIR test, they accept that form as an equivalent and correct answer, but we're going to go ahead and simplify it and put it into slope-intercept or y equals mx plus b form. So what I'm going to do is distribute that -4. Remember, this minus minus makes a plus, so -4 times +3 would be -12. And then I'm going to add the 5 to the other side to get y by itself. So it will be -4x and then -7, and hopefully my mental math is correct. Okay, and then on the next one, write the equation of the line perpendicular to this one. So we're going to have to change the slope and make it the opposite reciprocal. So we're going to flip our fraction and make it 1/4, and then make sure that the signs are opposite signs. So this was negative, and now it's positive. And then we're going to pass through this point. So we are going to do y minus the y value from our point equals our slope, and then x minus the x value from our point. And we're just going to simplify. So y plus 2, and then distribute. So 1/4 x, and then 1/4 times 8 is 2. And then we're going to subtract 2 and subtract 2 for a final answer of 1/4 x minus 4. Okay, if you are a little unsure on these, we will do more practice when we see you in class again.